It does. It has that. It has a vertex. And if you want to be specific, I like that. Let's put that. It has a vertex, meaning that one point. And so does the pyramid. So I like that word. Let's put that word. That's good. Vertex. Okay, and then what else do you notice with a cone? The circle base. And with the pyramid, what do you notice? I can't tell if it's square or rectangular, so I'm going to put rectangular base. A rectangle base. But it doesn't necessarily have to be a rectangle. We're going to skip some of the fancier examples because we're running low on time. It could be like a hexagonal base, like the prisms we were working with the other day. It does not have to be a square or a rectangle. It just can't be a circle. If it's a circle, it's a cone. Okay, so let's keep them straight. The cylinder obviously is not pointy, but it has two circle bases, whereas the cone has one circle base. And then with the pyramid and the prism, again, the difference is how many bases do I have? If I have two bases, I'm a prism. Just the one base, and I'm a pyramid. And then you have to be able to identify that base shape. So if you would like to color in the base shape to make your life a little easier, that's always a good idea. At least then I know you can identify the base. If, after today's notes, you want to come in and add more descriptions to this is your handout, make it useful. If Harrison needs to add some more stuff like ice cream cone, he can. And if he wants to come in and add the volume formulas on his handout, he sure can. If this is going to help him study. I was hoping this cheat sheet would help him study and keep his shapes straight. However, he's not going to get to use it on the test. He's literally, I'm serious, he's getting this yellow handout on the test. So if he wants to start practicing with this, he can. Okay, we talked about on Friday something called lateral area and something called surface area. What was lateral and what's surface? What's lateral area? What was my key word for lateral? Like with my water bottle. The lateral area, what are we finding? Oh my goodness. Will somebody be smart and pull out your notes and find an answer? Okay, and we lateral, and there's another L word that goes hand in hand with that. Label. Lateral is the label. Like if we want to stick it on the four lateral sides, the four lateral faces, and we talked about maybe we want to put a label all around the sides of my prism here, but not on the top and the bottom, not on the bases. And we want to wrap the whole thing, that's the surface area. When we include the bases, that's the surface area. And that's why in the formula for surface area, it was 2 plus the bases. 2, and the B was for an area of a base. Oh my goodness. So if I were you, not only should we do the bell ringer, but we probably better write down some notes about those formulas again. So let's see. I saw some people did the bell ringer. They subtracted 27 from both sides. Thank you for those who did the bell ringer, like they were supposed to in a timely manner. Plus 6x minus 27 equals 0. What are my two factors? 9 and 3. Plus 9 and a minus 3. So you do end up getting x equals negative 9 and x equals positive 3. I'll give you that. But we're just going to stop there. So all it said was factor and didn't say solve. So I'm going to stop there. Okay, but clearly we've forgotten over the weekend what we were talking about last week. So let's go over the lateral for a prism. The lateral area for a prism was L equals PH, where the P was for what? Perimeter of the whole shebang. It was perimeter of the base shape. We also used the formula, oh wait, we haven't done the H. What was the H for? Okay, but be specific, because we ran into an example where it wasn't the height we thought. Can I see your notes from last week, ma'am? Because you would have thought on our example 2B last week, you would have thought the height was 8. But in the formula, we put in the height as 10. So be more specific about that height. What are we actually wanting? The length doing what? Okay, length connecting the bases. Okay, we also use the surface area formula for prisms. This is for prisms. I'm not even going to bother going over the ones for cylinders because the only real difference is like the pi and the r, and you know r is for radius, so you're okay now. The surface area one was L plus 2B. What is L? L was for lateral area. We take our old number, and now we're adding in those bases. That's why it's 2B. But what is the B for? Is it for base? What is the B for? Okay, I love you dearly, but I'm just handing you the formulas for the test on Friday. If you don't know what the letters represent, you're in a whole mess of trouble on your own. Area of the base. Now, Miss Jessica wasn't here for our notes, so she can be a little confused. But you were here, and we saw it was mostly plug and chug. But if you don't know what each letter means, how are you going to plug in a number and chug out an answer? It's a little difficult. Okay, are there any questions about the prism formulas? The cylinder formulas look really similar, but they have pi's and r's for the pi and for radius. Okay, so today we're doing new notes, new formulas, new shebang. Yes, dear. Yes, dear. Now, no, we're just going to go straight into it. You don't have time for all that today. Let's go straight to the formula. Let's see. The first blank is pyramid, because we're talking about pyramids today. If you want to read a description of a pyramid about, like Ayana said, it has a common point called a vertex. If you want to read that whole description, you can. Otherwise, I am going to summarize for you. We, again, have two formulas, one for lateral, one for surface. The lateral formula is 1/2 PL. The P is still for perimeter of the base. We just need to figure out what that cursive L is for. And it's for something, if you read above, it's called the slant height. The slant height. So, if we read above, it says the height of each lateral face is called the slant height. And if I were to get out my pyramid, which I should have done earlier, let me get it out now. I don't know what it is in my pyramid. No, it's not in there. Oh. You know what? I have a shape that kind of looks like a pyramid, and it'll do. So, last week when we were talking about height, we wanted the number connecting the two bases. For the slant height, it's not, you would say maybe it's, you see my Eiffel Tower, maybe it's that big long wire going straight all the way down, and that's not the case. The slant height is one that's on the side of the pyramid, the number on the side. So if we look at our first example, that slant height on that side is 5. And of course, as you can imagine, sometimes they're not going to give us the slant height, and we could potentially need to use the darn Pythagorean theorem. But we'll get to that in a second. For our first couple examples, it's very straightforward. So L equals 1/2 P times the cursive L for slant height. I know my cursive L is 5. Now to find the perimeter of the base. What is that base shape? Is it? Read the directions. Is it a rectangle? It's a square. It says it's a square pyramid. So what is the perimeter of this square base? Is 2.5 times 4 10? I don't know. Yeah, it sounds like 10. Okay, so 1/2 of 50 is 25. So our lateral area is 25 centimeters squared. Okay, is there anyone who doesn't understand where we got the 10 from? Okay, we're adding at the perimeter, so 2.5 plus 2.5 plus 2.5 plus 2.5, it ends up being 10. Okay, so let's do the exact same thing on the next one. L equals 1/2 P times L. Can someone tell me what the P is?
Perimeter of the base.
Yes. Can you give me for this problem?
Oh, sorry.
Yes, because there's 4 sides, 4 plus 4 plus 4 plus 4. If we added them all up, we would indeed get 16. And then what is our slanted height? It is 8. So 1/2 of 16 times 8 ends up being, yeah, 1/2 of 8, yes, it ends up being 64 inches squared. Because 1/2 of 16 is 8. 8 times 8 is 64. Or you can always tap it in your calculator. Okay, so lateral area of a pyramid seems fairly easy as long as they've given us the slanted height. The only potential problem is we might have to solve for the slanted height, that L. Okay, it's like I'm giving away my own secrets. If we look at the surface area formula, it's got everything we would expect in it. It's got P for the perimeter of the base. It's got the L for slanted height. And like with our other surface area formulas, it has the B for the area of the base. Now our other formulas were 2B. For a prism and for a cylinder, it was 2B. How come with the pyramid, it's just plus B, not plus 2B? Because there's only one base. There's not 2 bases. There's only one base. That's why this formula makes sense. So if Jarrell picks the wrong formula because he thought there were 2 bases, he's already in trouble. Okay, so our formula S equals 1/2 PL plus B. But again, really this 1/2 PL is that, if you're looking at your lateral formula, is the lateral. So again, Harrison's finding the lateral, and he's just adding the area of that base shape. Okay, so the perimeter of my base I got to figure out. I need to figure out the slanted height, and I've got to figure out the area of my base too. Goodness, I've got 3 things I have to plug in for this one. One thing at a time. We know it's a square pyramid, so what is the perimeter of our base? Yes, because 8 times 4 is 32. So the perimeter of my base is 32. Okay, what is the area of my base? Yeah, and that makes sense because my base is a square. The formula for a square is base times height. I know it's 8 times 8, so I know it's 64. So I can plug in a 64 there. Is there anyone confused about the 32 or the 64? Before we make life any more complicated. 8 plus 8 plus 8 plus 8. Or 8 times 4. Okay, and then of course, it wasn't that this one was hard enough. We're going to make it a little more complicated. We don't know that slanted height. I see it drawn on the picture, but there's no number there. So we're going to have to solve for that. Okay, but we're smart, and I'm going to draw me a little tiny picture down here. We're smart. We see that there is a triangle. It is a right triangle. We can tell the number at the bottom is 4. The number going up that leg is 6. So we need to solve for that hypotenuse. We do. And you would say, Ms. Compton, is it a triple? And it's not. It is not. So what do we use to solve for that hypotenuse? The Pythagorean theorem. So 4 squared plus 6 squared equals x squared. I'll put an x on it. So 16 plus 36 equals x squared. 52 equals x squared. So x is some decimal you can find if you type square root of 52 into your calculator. But me, I'm a little lazy, so I'm just going to plug in square root of 52. Because I really could type that entire line just like that into my calculator. Okay, so let's say that all again. We found the perimeter of the base. We found the area of the base. We need to find that slanted height because, darn it, third example of the day, they did not label it for us. We noticed they had labeled this right triangle for us. So we solve for that slanted height using the Pythagorean theorem. Now that we have that slanted height and we're done, we can plug this in and finally find the whole surface area. Okay, when you type this whole line into your calculator, what do you end up getting as your surface area? And it says nearest tenth, so I need 1 decimal place. Somebody out there. I'll cave and let you have it out if you're going to use it as a calculator real fast. I just need an answer. 179. I got 0.4. But Catherine, if she has showed her steps for the perimeter, her steps for the area, her attempt to solve for that slanted height, so she doesn't have the right decimal, I don't count off much if her line right here is correct. I count off maybe a point. She went from 100 to a 99. Are there any questions about that one? Well, then let's do one more. It's very similar. So we have 1/2 PL plus B. I need to know the perimeter of my base. My base is still a square pyramid. My base is still a square. So what is the perimeter of my base? Yes, because 6 times 4 is 24. Or if you added up the 6's on all 4 sides, you would get 24. Is everyone good on the perimeter? We'll come back to that slanted height in a second because this is another doozy. And then we need the area of that base. It's a square, so it's base times height. So 6 times 6, you do get 36. So I know the area of my base shape is 36. Now I'm annoyed because here I am. I want to know that slanted height. And they didn't tell it to me. But again, I see this right triangle inside this pyramid. I'm going to draw it down here as well. I see a right triangle. I need to solve for that hypotenuse. I know it goes up 8. And then this one's not as nice because they didn't tell me what number to put on the bottom. I'm going to have to use my brain to figure that out. If this is happening exactly in the middle, how many over should I be? If it's 3, because it's 3 plus 3 would be 6, and we're happening exactly in the middle, so this would be 3. And if we look back at our other one, the same magic happened. They just labeled it for us. The whole length was 8, so halfway from here to here was 4, and from here to here would be 4 more. They were just nicer to label it on that one than they were on this one. This is sadly not a triple again. It's terribly annoying. So I'm going to have to use that Pythagorean theorem. 8 squared plus 3 squared equals x squared. 64 plus 9 equals x squared. 73 equals x squared. So I've got square root of 73 for x. Now you can type in that decimal if you'd like to write that down instead. And I think it's just easier to plug in square root of 73 into the formula. Okay, you type that entire line in your calculator and I get some sort of decimal I need. We're going to change it all to inches. Inches squared. It is 138.5. But again, if Derek makes a mistake between here and here, he loses maybe a point. The fact that he has all the right numbers in all the right places is going to get him most of his point. Now, he doesn't want to make the same mistake he made on that 11.1 and 11.2 quiz and not show any work and like pull 138.5 out of thin air, because what if he pulls the wrong number out of thin air? He's got to show me what went on in his brain to find that perimeter, to find that slanted height, to find that base. Are there any questions about the pyramids? They would be easy if they wouldn't make you solve for that slanted height. Okay, then flip to the back. We've got to deal with the cones too. We're on a kick. Oh, more pyramids. I have some really good news about these. We are not going to do this one or this one. They're out for us. We're not going to do them because we would have to find the area of the base, and the base is a hexagon. And that's a little much here on May 1st. I acknowledge that. So I'm going to let those go. And we, for real, we'll move on to cones. Okay, so cones still have a lateral formula. They still have a surface area formula. I'm going to highlight them both. A cone is different from a pyramid because, like you said, it has a circle base. What's annoying is there are different kinds of cones. There's an oblique cone, which is not very centered, and then like a right cone, that's what you normally put your ice cream in, a right cone. And if we look at the formula, we're good with the pi and the r, and darn it, that L is back. But thankfully, L still stands for slant height. So notice that slant height is still on the side of the cone the way it was on the side of the pyramid. It's not going directly through the middle of the cone. It's on the actual edge. So if I had a cone in my hand, it would actually be on that crispy edge. And then there's nothing much going on with the surface area formula except they've added in this. They said pi r squared. What formula is that? Pi r squared. Yeah, it was the area of a circle. What is my base shape in a cone? So really, it's still the same formula where you take the L and you add in the B, because this is the same thing as L. And then this is still the area of pi r squared, and B would be the same thing because it's still the area of the base, because the base is a circle. So it's not like we're going crazy and inventing a whole new formula. It's still in the same realm. And just like with pyramids, we're only finding the area of the base. It's not 2B, because there aren't two bases. There's only the one base. Okay, so darn it, this one has words and they didn't even draw us a picture. So L equals pi RL. Goodness gracious. His confidence and lost their mind. Oh, I know why. Show me your worksheet from Friday, please, ma'am. The worksheet, not that worksheet. Alan. Yes. Okay, so I looked at your worksheet and I was thinking, oh, we can get those and we can. I knew we could. Okay, what's annoying is they didn't show you a picture. All the ones on the test will have a picture drawn for you, just like all the ones on your worksheet have a picture drawn for you. Sadly, so we need to find first things first. First things first. Let's get it together. First things first. What is the radius?
1.25.
Okay. You think you're perfect, and you're not. There are like 4 in the room who keep plugging in the diameter for the radius. The diameter is, if we have a circle, the diameter is the whole length. The radius is just half of that. So if you're given the diameter, you need to cut that in half to get your radius. And I plugged that in the wrong spot, didn't I? I did. Now to find the L. The L is over here, and sadly we've got us another Pythagorean theorem issue. So we end up having to do 1.25 squared plus 8 squared equals x squared. Again, the Pythagorean theorem. So if there's something you should take away from pyramids and cones, is that they find a way to put a triangle in there. So we need to solve this, and the reason we're doing this is because we weren't given that slanted height. Instead, we were given the altitude, which is the number going from top to bottom. But does Harrison have to remember that vocab term for me? No. He just needs to know that number is not the one he wants. He wants the one on the actual cone, so he has to solve. I know this is 64. I don't know what 1.25 squared is. I do not know. Someone has a calculator and would like math class to end sometime today. One point 1.6?
Yeah.
1.56? Which one?
1.56, but if you round it.
Don't round yet. Okay, so we would get 65.56 equals x squared. So we need to take the square root of 65.5 for x. We would type this entire decimal in our calculator to get our answer. He's trying to annoy me. He doesn't know me that well. I'm going to let it go. If I were to make Harrison do this exact next one, would he at least realize that the diameter, half of that would be the radius, which is 2, and then again he's going to have to solve for the L? If I were looking at, Catherine, give me a number to plug in on that. I stole it from you already. Okay, if I were looking at your worksheet The good news is they don't put any words. There are no words. The bad news is, I took credit from her. The bad news is, where's your worksheet? You have to solve, if you want to put a star by, you have to solve on 1, 2, and 4. Thankfully on number 3 they gave it to you. But heck, Ellie might as well put a star by 3, because although they did give her these